Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at java.util.concurrent and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about the wait, the notify, and the notifyAll methods. Now these methods are in the object class, which as you should know by this point is at the top of the Java hierarchy. And specifically, these methods relate to multi-thread communication, right? Communication between various different threads. So I'm going to open up my web browser on my website, java.util.concurrent, select begin, and scroll all the way down here to the wait and notify methods. Now you want to make sure that you've watched my other tutorials and understand specifically the word keyword synchronized and how that, what that does there before you continue on with this one. But anyway, let's go ahead and dive in here. So there are a total of 11 methods in the object class. 3 of those methods are overloaded versions of the wait method. Combine those 3 with the notify and the notifyAll methods and you have almost half of the object class methods grouped up. Now what does this group of methods really do? Well, they represent the primitive core communication methods between threads. I went back and forth on whether or not to create a tutorial on these methods because they are pretty much legacy now. The java.util.concurrent package contains many classes and methods that will handle communication between threads in a much more efficient manner. Now, you will need to have a general idea of how a monitor lock works so you can understand the necessary overhead that comes with using these methods. Before I continue on, before you start using like the concurrent classes and methods and stuff like that, it's really kind of a good idea to see how this all evolved and have a good core understanding of it. So, and monitor lock is, you'll hear this term a lot. It's also called an intrinsic lock too as well. So, but let's talk about what the monitor lock really is. And I'm going to use a simple analogy of how a ship or boat lock works in order to describe the stages of a monitor lock. Now, the Panama Canal allows ships to cross back and forth from the Atlantic Ocean to the Pacific Ocean. There are actually numerous locks in the Panama Canal, but for purposes of this tutorial, imagine there's just a single lock. The area between the lock gates is where the water is pumped in or out to make the water level either rise or fall. In my analogy, this area inside of the gates represents Java object state. Now, if we allow 2 or more ships into the lock gates at a time, we will create a dangerous situation with dire consequences. So we have to synchronize operations by only allowing 1 ship to be inside the gates at any given time. Now, the same thing applies to object state when you have multiple threads trying to access instance variables via methods. Any methods that access the object state must have the synchronized keyword applied. Now that we have the rules of a lock established, let's get some ships, threads per se, through the locks. You are the captain of a giant shipping vessel named the Thread, and you are approaching the canal on the Atlantic side. Now as you near the canal, you notice that there are other ships already waiting there competing to see who can be the next one into the lock gates. At this point, you are attempting to enter the canal, so collectively, your ship and all the other ships are part of an entry group or an entry set. Now, just before the canal gates, the entrance to the canal is only wide enough to fit ships in a single file line. As luck would have it, the other captains have fallen asleep, so you are able to maneuver your ship right into that skinny channel and you are now waiting just outside of the lock gate. At this point, you have acquired the slot to be the next one in the lock gates. In other words, you have acquired the lock, technically, when you're talking threads, okay? So the lock gate in front of you opens up and you maneuver your ship into the area inside of the gates. Now the gate closes behind you and you now own the lock. A little typo there, right? At this point, you have exclusive access to the lock, right? The object state, and you could sit back while the water is pumped either in or out, right? Synchronized, and that represents basically like synchronized methods doing their thing. They either modify or access the state. Now, once the water level is properly adjusted, in other words, your synchronized method has finished executing statements, the gate door will open in front of your ship. You then maneuver your ship out of the lock gates down a thin channel before you hit the open ocean. Now, when your ship is in this channel and the gate is closed behind you, your ship has now been released from the lock, right? In other words, your method has released the monitor lock. Now, once you exit the channel, you are free to navigate into the Pacific Ocean. You have exited the monitor at this point. And that is basically my general overview of what a monitor lock is. So let's just go ahead and move on here. So what do these three methods do? So let's talk about wait first. It causes the current thread to wait, in other words, give up the monitor and sleep, until another thread invokes the notify or notifyAll. Right? The notify method wakes up a single thread that is waiting on the object's monitor, right? And it should be the first thread that called wait, right? And then notify all, that method wakes up all the threads that are waiting on the object's monitor. And I'm not going to actually use that in today's tutorial just because it's going to get too long-winded if I do, but it's fairly simple. Once you understand wait and notify all is just, it's really Dr. Seuss at that point. So we've got to talk about something called a spurious wakeup. And this is really annoying that we even have to deal with this sort of thing, but we do. And you know, no language is perfect, no operating system is perfect, and this is one of those things that kind of throws a big problem in there. But let's talk about this for a moment there. It's going to lead to a level of certain confusion, but I will sort all that out in the actual when I do the coding stuff there. So now, based on the description of the methods above, it should be fairly simple to use these methods to coordinate thread communication. But wait, there's more. So what is a spurious wakeup? A spurious wakeup is when a thread is in a waiting state, then wakes up from the wait state for no reason at all. Other waiting threads did not call notify. I shouldn't say other waiting threads, but I should say other threads did not call notify, right? Spurious wakeups are allowed to happen at the JVM level, meaning the JVM is allowed to essentially sort of call a notify all for all current running objects. Now that throws a serious monkey wrench into this whole equation. Now to my knowledge, my code has never actually experienced a spurious wakeup, but if you Google, Java spurious wakeup, you'll see that it is in fact a real issue. Now in order to account for a spurious wakeup, we must enclose our call to the wait method inside of a loop that checks to see if the condition that we're waiting for has actually occurred. Confusing? Oh yeah. I'll just stick with me. And it'll all make sense by the end of this tutorial. And might not all make sense by the end of the tutorial. You might have to watch it a couple of times because if this is a new concept for you, it really is kind of a confusing thing. So now in this tutorial, we are going to take the lather, rinse, repeat instructions found on many brands of shampoo seriously. Throughout the video, I'll be adding a lot of code that is not in the code below. So you definitely want to watch the video because if you run this code that's right here, it's not going to do much there. I'm going to add a bunch of stuff to it, but I want to keep it as simple as possible to start off with and then just kind of add building blocks as we go. So let's come down here and highlight the source code. Control-C to copy or right-click and select copy. I'm going to move my browser off screen. I've got a shortcut to the command prompt on my desktop, but if you don't have one, you can right-click, select New, Shortcut, CMD, next and finish. It's just that easy. All right, let's go ahead and open that up. Type in javac, which is a Java compiler command. Press enter. You should see all this stuff scroll by. However, if you receive an error message, watch my tutorial on installing the Java Development Kit. I want to make sure you get that installed and configured properly before continuing. CLS to clear the screen. CD space / CD is short for change directory. / tells it to go to the root. I'm going to make a directory using the MD command called Java, and I already have that folder, but if you don't, I'm going to go ahead and create one for you. Change directories to the Java folder. I'm going to make a directory here called wait notify. Just change directories to wait notify. And I am going to notepad wait notify.java. All right, wait notify.java is the name of my source code file, also known as a compilation unit. I'm going to go ahead and came open on my other window there. Let me move that back over there. Okay. Don't go away there. All right, so we've got our wait notify Java here. I'm going to Control-V to paste that stuff in there. And give me just a second there. Minimized all my stuff on accident. All right, so I'm going to come up here and save this here. So basically what we've got is we've got three classes inside of here, right? The class wait notify has the main method entry point, and I'll be getting back to that here in a second. But let's talk about this class called clean hair, right? Clean hair has a single instance, string instance variable, current state, right? And this is going to be our object state. And then it has two methods. Both are void return types, lather and rinse. And you'll notice I've applied the synchronized keyword to them there, right? Because without synchronized, wait and notify, absolutely nothing, right? You have to use that, right? Matter of fact, I think you'll get an error message exception actually if you try to put them in a method without the synchronized keyword on there. So let's talk about these two, right? Very simple, right? Lather, we're going to change the current state to lather, and then we're going to display the current state to the console. Then we're going to call the notify, right? Invoke the notify method, and then we're going to invoke the wait method, right? So notify will notify any other threads out there, hey, we have modified the current state and we've accessed the current state here. In other words, we're like kind of like inside of that lock, right? At this point in time, right? We're inside of the the boat locks, the canal locks there, right? We have exclusive access to it. We're doing our thing. Then when we call notify, we're leaving the lock and we're releasing the lock, and then we're just gonna wait, right? Wait will cause our thread to go into a blocking mode, by the way. So, and of course, with the wait method, we have to catch an interrupted exception on that. So that's why it's enclosed in a try on that. Notify, we don't have to try or catch anything on that, right? Okay, and then rinse down here, same thing. The rinse method here will, because it's synchronized, it'll have a lock on it there, right? And it'll be able to, it'll change the current state up here to rinse, the instance variable there, and it will actually then access it to display it to the console. And then we'll call notify and then wait. Okay, so that's the purpose of just these two methods inside of our clean hair class. So let's come down here to my thread class here, and I call this one hair thread, and I'm extending thread instead of runnable, and that's, well, I was going to do some wait stuff there, but anyway, we'll come back to this in a second on why I did that. But so inside of this hair thread here, I've just simply got a name, which is going to be the name of the thread there, right? And then I've got a reference variable, clean ref, that's going to point to our clean hair object that we're going to receive in our constructor here for the hair thread, along with the name, okay? So when we create our thread up here, right, let's come back up to the wait notify class here, and inside the main method entry point, the first thing I'm going to do is create a clean hair, clean reference variable of clean hair type and set that equal to the new clean hair object. So here's our single object for this whole entire program, right? That these two threads are going to be competing for to change its state. And this is the object state of this single object, clean hair there. Okay, so I'm just going to have two statements here, creating a new hair thread object and passing it the name of lather, right? And that's because we want this thread here to only invoke the lather method here when it's run, and we want this hair thread object, to only invoke the rinse method when it's run, right? And these guys are going to talk back and forth to each other to let each other know that, hey, I changed the state, now you can have it. Okay, I changed the state, now you can have it. And so on and so forth there, right? And so it'll just display lather, rinse until the end of time. Okay. So let's come back down here to the hair thread class, extending thread obviously. So I've got the name, and the reason why I've got the name being passed in here is because I am going to, first of all, I'm going to set this.name, which is the instance variable on that, and then we're passing in, the reference variable, clean ref there, setting that equal there. And then I'm invoking the set name method out of the thread class there, right? And setting that in equal to, basically either, lather or rinse, right? So the set name method in the thread class will actually name that particular thread. And that basically comes into play a little bit later there. And then I'm invoking the start method. Now the start method, if you've been watching that, simply turns around and invokes the actual overridden run method here that I've got right there. So I'm checking to see if the name equals, right? And the name will be basically the name of the current thread there. If it is equal to lather, right, then we're going to invoke the cleanref.lather method. Otherwise, if it's equal to rinse, we'll invoke the cleanref rinse method up here, as opposed to when we create these two objects here. So let's go ahead and run this here real quick. And let's clear our screen. Let's compile this. And let's run it. Wait, notify. All right, so press enter. So we get rinse, lather. All right, and then it's just sitting there, and you notice something's blocking. What went on here, right? And let's hit Control C to break out of this, and let's run it again. And now we get lather and rinse, right? And let's hit Control C again. Let's clear our screen, and let's run it again, right? We get lather, rinse, and it's blocking. So what do we got going on here? It isn't quite working exactly how we'd expect. Well, what we've got is when we create this first lather thread right here, right? New lather thread. It comes in here and it starts it up and it says, oh, okay, I'm equal to lather. I'm gonna go ahead and invoke the lather method on our single object up here, right? Which we're passing across there. So it comes in and it says, okay, our clean hair comes in and says, all right, lather. So we're gonna change the current state to lather. Lather, display that to the console, right? Which is what we've done right there. And then we're going to invoke the notify method, and then we're going to wait, okay? So by invoking the notify method, this new hair thread that we created up here, right, simply comes up and it says, okay, I am a rinse method, so I am going to invoke the rinse method, okay? Now, because the rinse method is synchronized, once it receives, it can get access to that. It changes the current state to rinse and then calls notify, right? Now, the second it does that, it displays rinse, calls notify. Now, our first thread up here, that's basically our lather thread, right? Says, oh, okay, I can now, wait, just basically it sits right here and it waits, right? Once it hits once this notify is called here, that tells the other thread, the lather thread, that we can go ahead and continue on from the wait method, and there isn't anything there. So it goes ahead and just says, oh, okay, all right, let's see, wait is done, so we just, we want to continue on, and that tells it to come down here in the run method, and it says, okay, this statement is now finished, right, for the lather. What else do we have to do? And the answer is nothing. So this thread up here will then go ahead and exit. It's gone and go away. Now the rinse thread at this point in time is still sitting here at wait. There's no other thread that's going to call notify at this point in time. So this guy is just sitting there, basically blocking at this point, right? He's blocking, waiting for someone to call notify, and that's never going to happen because our lather one here with the notify in it is he's gone. He went away. So how do we fix this particular situation? Well, Control C to break out of that blocking method, that loop there per se. Well, it really wasn't a loop. And let's come down here to the run method. So we want to keep on invoking the these methods, right? So whenever wait is done here, right, we want to go ahead and then invoke the lather method again. So we're going to go ahead and put both of these in true loops, in endless loops, right? Excuse me. And so they'll be able to talk back and forth to each other now. So let's go ahead and come up here and save this. Let's clear our screen. Let's recompile this. And let's rerun it. Okay, so I'm going to hit Control C to stop this. Otherwise, these guys are just going to sit and talk back and forth forever, right? Lather, rinse, lather, rinse, lather, rinse, right? And we can scroll, up through here and see that we've got lather rinsing, right? And so our communication between these two threads is working perfectly. The first guy comes in and says, okay, I invoked my lather method, and now I'm going to notify him, right? And then I'm going to wait, and then it comes back, and the next guy says, oh, okay, I invoked my rinse, I'm going to notify you, and wait, and they keep talking back and forth. Okay, you right, all right, you change it, all right, you change it, you change it, you change it, you change it, right? And so they're using the notify and the wait very, very effectively there. So that's, if it was just that easy, you'd be thinking, okay, all right, this is great. We can communicate back and forth between the threads. We could do something. We wouldn't even have to do like an endless loop. We could maybe only, if we wanted to do a for loop and only do it like say 10 times each, right? We could do that as well. Something like for int I, equals 10. 10. and I equals 0. What am I doing? I is less than 10, I plus plus, right? Then that would cause each one of them to, basically only run 10 times instead of infinitely. And let's go ahead and just recompile that. And let's rerun that, right? And so we've got our lather, rinse, lather, rinse, lather, rinse. And of course we know it's hanging on the very last one here, because once we exited out of that for loop, right, the lather thread is gone at this point, and the wait thread is up here basically, or the rinse thread is up here sitting in this wait method here forever, right? So we'll go ahead and break out of that. I'm going to put the while back in there. So let's talk about this spurious wake up there. This damn like black unicorn that comes along and screws up our really effective, communications and everything like that, right? And so how do we account for that? I'm gonna just go ahead and save this and show you that we're back to our, endless looping on that there, right? And with our lather rinse. So a spurious wake up could cause, let's say for example, it could cause us to print a couple lathers in a row or a couple rinses in a row, or maybe like 10 of them in a row, who knows, right? But it basically causes these particular instances to wake up out of their waiting state and go ahead and execute. So what we have to do is we have to basically, let's enclose these in, well, let's take a minute to think about this here, right? When we wake up, we set our state to lather, right? And we print lather. And when we wake up from this wait here, what should the state be in this particular method, right? Well, the state should not be lather, right? It should be rinse. So what we want to do is we want to, if we wake up and we do something like current state equals, if we wake up and the current state is still equal to lather, we want to go back to sleep, because that's not what we're expecting. We're expecting the current state at that point in time when we wake up to be rinse, right? So if the current state equals lather, then we have had a spurious wake up and we need to just go back in and wait again, okay? So that's how we account for a spurious wake up, is we check for the condition of whatever we're checking for, right? In this particular case, if we wake up and it's equal to lather, oh, we've got a problem. That's a spurious wake up occurred, okay? So we just enclose this wait down here as well in a while loop, right? While current state equals, in this particular case, if the wait wakes up and the current state is equal to rinse, we've had a spurious wake up, right? So all right, so that's how we fix our spurious wake ups, and that's well documented. You look on there and everything like that, and or research it out there. But that's basically how you do it there. All right, so let's come back up here and save, and let's clear our screen. Let's recompile. What am I doing? All right, let's run it again. All right, so basically we get I'm gonna do Control-C to stop that endless loop, and we still end up with our, lather, rinse, lather, rinse, lather, rinse, lather, rinse. It looks just like the way it did before, and we now know that we have our code in here to basically account for a spurious wake up. So in this particular case, now we've got our code kind of bulletproof there. The lather rinse is going to go on forever. These guys are going to talk back and forth and keep trading off, the state there, right? Okay. All right, so I'm going to go ahead and just get rid of that, and leave you guys with some final thoughts here. So if you find yourself in a state of frustration, after watching this, frustration or confusion, it's really a good thing. That means you are learning. Some new concepts take a while for, to sink in. I would just recommend, try waiting a day, watching the tutorial again, or watch it again and wait a little time. They just have to sink in there. So anyway, that concludes this tutorial. Thanks for watching.